Good morning, everybody. We're going to talk a little bit about continuous testing and how that is beyond test automation. I'm Gerie Owen, I'm the QA evangelist at Qualitest Group. I'm a speaker and writer, and I've been doing DevOps and Agile and testing for my whole career. Um, we'll start by explaining what continuous testing is, and then we'll talk a little bit about implementing it and how we're going to develop a strategy for continuous testing, and then finally finish up with a little bit about monitoring and production. So, what is continuous testing? Well, capability in Agile and DevOps where all test activities run continuously in an integrated fashion with development and delivery. Immediate bug fixing is enabled, test environments are provisioned instantly, and unit functional and non-functional tests are run in an automated way, and it's all orchestrated by continuous delivery and continuous automation tools. Well, that's kind of a mouthful, but it's an approach to managing business risk. So why would we implement continuous testing? Well, if we think about it, DevOps is about continuous delivery, and our test cycles must be shortened. Regression test suites that run overnight just don't cut it anymore. We have an increase in microservices architectures, and those especially require high quality functional testing, and that usually includes automated API testing. And finally, our builds and integrations and deployments are automated, and we not only have to test those, but we need to test the entire pipeline. And all of the automated testing, including the builds and integrations, um, need to be involved in our continuous testing strategy. So let's talk about some of the attributes of continuous testing. Well, as I mentioned before, it really it's an approach to managing business risk. um, business business risk coverage is really the primary goal. Um, it it's used to establish a safety net that helps teams protect the user experience. When you're delivering multiple builds a day or even a week, um, bugs are going to get into production. It's not we can't have 100% test coverage anymore, but we need to be able to do a lot of risk analysis so that the bugs that do get into production are not the ones that are going to impact user experience. And then when we get into talking about continuous monitoring, we'll talk about finding those bugs before they actually cause users any problem. Continuous testing requires stable test environments to be available on demand, and we need to be able to spin those up using service virtualization. Um, Continuous testing integrates seamlessly into the delivery pipeline and the DevOps tools chain. It's really the backbone of the tool chain when you think about it, because without testing, we won't have quality. And quality and velocity are the keys in DevOps. And finally, continuous testing delivers actionable feedback at the appropriate stage for each stage of the delivery pipeline. And the feedback is usually is automated. And that's one of the really important keys to the whole process. Um, there's a difference between continuous testing and test automation. In traditional test automation, we write our test scripts, we automate our test scripts, and then we run them, and we wait, and we review the results, we make adjustments, we fix bugs, we run them, we wait. So we've got wait time in there, and wait time impacts efficiency, and it also delays feedback. And in continuous testing, we're testing the builds and the integration and the whole pipeline. So there's no human intervention there. The whole process is smooth and seamless. So how do we implement continuous testing? I guess that's the big question. And yeah, it's more easily said than done. It takes a long time to really get the whole process working, and we need to just take it a little bit at a time. We we should start with the risk analysis portion, because the risk analysis and the process improvements are really key. You want to make sure in the risk analysis, you need to be looking at what's important to your business and your customers. Process improvement. You want to streamline everything. You know, not just your test planning and assessment, but your entire in find any bottlenecks in the pipeline. We want to be able to increase the velocity of the current quality assurance processes. We want to implement automated testing through the entire software development process. And finally, but really most importantly, we want to develop a culture in which the entire team is responsible for quality. And that one can be really tough because, you know, as much as in DevOps as we work to eliminate those silos, it is difficult to get a real culture where everybody on the team is going to put quality first and be really sure that everything that they do meets quality standards. So let's talk about some of the key practices of DevOps, of continuous testing. Some of these are ones, of course, that we're already doing in testing, and some are new in that we're taking some of these practices further than we have before. To start with is defect management. Of course, we've always managed defects, but now rather than putting them in the bug tracker and throwing them over the wall, we want to discuss them with our developers as observations before we even log them. I mean, that way, that again, putting bugs in that don't turn out to be bugs, that's a bottleneck. So if we talk about our bugs first, then maybe we're not even logging them. And defects that are truly defects, we want to fix them immediately rather than do all this logging and tracking. Of course, there are ones that we can't fix immediately, and we will log and track those. But if we're fixing the critical ones, then we're eliminating bottlenecks. Test case management and optimization. I mean, yeah, we've always managed our test cases. But what we're looking here is really the optimization, and we'll talk further about this later. But we want to be analyzing all of our test cases for their quality and their effectiveness, and we need to evaluate the test suites to make sure that we're getting the maximum amount of coverage with the fewest number of test cases. We're never going to be able to test everything anymore. That's something we just have to get used to. But we have to get all of the test cases that are going to give us the biggest bang for our buck and keep them working. And we'll talk more about how to some of the best practices for automating them. Advanced analytics. This involves using code change impact analysis for test optimization. When we do this, we can determine new tests that are needed, what old tests need either updating or to be replaced or eliminated. And most importantly, that's going to tell us what other areas of the code and the application have been affected and require regression testing. You know, coding is still human. There are going to be defects, and there are going to be defects in areas that we don't expect them. I mean, regression testing, even though we're not running these full regression tests every night, regression testing hasn't gone away. It's just that we need to really focus it. Environment. Environment's always been a bane of our existence as testers, but especially in continuous testing, we need environments that are easy to access, and they really absolutely need to be production-like. So we need automated processes for creating and verifying these environments. Using service virtualization and data management. Again, like environment, we need the test data that's most production-like. So we can employ service virtualization in deployment automation and test data creation. And shift left comes in here. Shift left is really critical, and we can employ it using service virtualization because we can begin the integration testing even though all our integrations may not be completed or available. And then, of course, the final practice of continuous testing, which probably is the whole backbone of continuous testing, is automation. And automating, we need to include all the layers of testing, not just not just the regression and the GUI. We need to look at the test pyramid. We need to begin our automated testing right in the unit test layer. And automated testing includes automating the deployment and including the health checks and the feedback at every step. So let's take a look at some of the components of our continuous testing strategy. Well, first we need to streamline the process. There again, it's not all about automation, it's a lot about our process. The entire team needs to champion quality and be responsible for it. Our goal is to improve both velocity and quality. We want to test throughout the build and delivery pipeline. We're going to implement automated checkpoints and shift left and shift left applies to both functional and non-functional testing. And finally, we need to implement a plan for continuous monitoring in both test and production. So how do we streamline the test process? Well, again, we have to focus on mitigating business risk. So how do we know? How do we know what our most risky scenarios are? Well, we need to talk to. It's a team effort. It's not something that just the testers can do. We need to find out from our developers what code is the riskiest. We want to find out from our product owners and business stakeholders what workflows are most important. We can even find out from our customers. If we talk to our help desks, we can find out where our customers have the most questions and what features they use the most. That'll tell us where, and of course, those features that are used the most, those are the ones that are going to be the highest risk. We implement test optimization, and this includes both the test scope, the test cases, and the test suites. Not only run automation tests, but we really need to get into running them in parallel. And we need to identify and mitigate our bottlenecks. So, focusing on the business risk, we need to focus on the customer. We need to talk about the aspects of the applications that are most important to the customer because those really are the areas of highest risk. We need to understand the competitive climate of the organization. Sometimes, so if we're building a self-driving car, well, we really need a lot of testing, and we can't afford any bugs in production. And in that case, it probably isn't that important to be first to production. The more important thing is to build a safe car. But in more competitive fields that you're producing a product that isn't safety critical, maybe you're producing a new innovative product. It may be more important to be first to market than to have a perfect product. We need to understand that because that will impact how much we actually test. We want to make sure we map all our application components, requirements, and tests. This doesn't mean we need to put together a big test matrix, but maybe use a mind map. We do need a streamlined method of determining that we have tested everything that's most important. We want to optimize the test suite so that we're providing the greatest risk coverage with the fewer number of test cases. We want to make sure we're getting the biggest bang for our buck. And we always want to report status in a way that highlights the business risk. And this includes technical performance, compliance. It, status reporting can be difficult because we, we, we want to we want to use it to tell a story. We want it to we want it to explain the business risk. And that's not necessarily the current measures that we use, the number of defects that slipped into UAT, the number of test cases passed. We need to look at some of the metrics that tell us that tell us more what's really going on. You know, where are the defects concentrated? How many of the critical workflows have we tested and passed? We need to tell the story of the quality and the risk of releasing that particular build. So let's talk about test optimization. Well, test optimization, you know, we think of it maybe with the test cases, but it actually involves three parts. It involves optimizing the test scope, the test cases, and then finally the test suites that we're going to automate. So let's talk a little bit about the test scope. To optimize the test scope, we want to begin by selecting end-to-end tests that focus on the critical and high-risk features of the application. And I think we've talked about how to do that. Again, you know, talking to our stakeholders, our business and our development, and as well as our help desk. We need to understand all the integrations involved. These are our critical user workflows, and usually those critical workflows are going to require multiple integrations, and some of these applications may even be legacy applications. We need to understand the technologies involved. You know, we're going to have web, mobile. We'll probably have a message and an API layer, and we need to understand all that, and maybe even map out the entire workflows. Then we can implement service virtualization for the integrations and the components that aren't readily available. And we want to make sure we use the most realistic data possible for each test. And if we need to, we can use synthetic data generation. Of course, when we use real production generation, we do want to be mindful of our GDPR regulations and make sure that we are not using data that our customers have not authorized us to use. And then, of course, we do always have to include some exploratory testing. And we should keep that at the top of the pyramid so that we can find our user experience bugs and other ones that aren't easily found by the automated tests. So optimizing the test cases. Well, the test cases should be focused on the functionality they're validating. That's kind of pretty simple, but sometimes we mix a bunch of different things into one test case. We want to keep them simple and short. The more complex the test, the more validation is going to be required to test the code itself. And even though service virtualization can fill in for the missing components, we want to really try to make the tests as independent as possible. And we'll talk about that with the automation best practices. Optimizing our test suites. The most important thing to remember here is that that's really an ongoing process. We can have a regression test suite, but we need a tracking mechanism to see how it's doing. And then we need to periodically clean it up and use metrics and use metrics to determine how we're going to do that cleanup. Because our features are constantly changing, we're constantly updating our applications, our tests need that same current and continual attention. Our test suites in DevOps are becoming obsolete much faster, and we have to constantly apply ourselves to managing them. So let's talk a little bit about that. We want to include the test cases that are the highest areas of risk in the code. We want to include the tests that validate customer-centric features and the critical business workflows. Then when we get into automation, we want to use tools that create multi-purpose scripts. This goes to shrinking the time for running our automation. We want to make sure that a tool that we use it works across platforms and browsers, and we should be able to get some performance information out of our functional test scripts. This goes to streamlining the test processes. We need to run automated tests in parallel. Now, because if we are running tests on only one environment, if we're just using our local environment, we're never really going to get the speed that we need. We need to be able to use multiple virtual environments, but in order to do that, we have to have our tests set up in such a way that we can implement them in parallel. And some of the best practices here include our tests need to be atomic. What that means is that we're only testing one thing per script. Because if we're testing multiple things in a script, if one thing fails, then our suite stops. Tests need to be autonomous. We don't want to have the next test relying on the results of the previous test. Because again, you'll stop your run. We want to make sure our tests run quick. And a good rule of thumb is to keep the execution time for each test to 1 minute on your local environment. Then on other environments, hopefully it should run faster. And then you need to be particularly aware of the data management. Each test should create and delete its own data. That way you don't get a lot of data out there that's just going to bog things down. Now, the next thing that we should talk about is identifying and mitigating bottlenecks. Why? Well, it's simple. Bottlenecks impede velocity, probably more than long-running test suites or anything else. Bottlenecks we can find anywhere. We need to identify them. We need to look at the consequences, and then we need to mitigate and manage, and try to put things in place that prevent future bottlenecks. So identifying the bottlenecks. They're usually constraints to the test process, and they can be found right from requirements through post-production checkout. Some of the examples, maybe testers aren't included in your backlog refinement, so then they don't have the opportunity to help build testable acceptance criteria. That's going to slow things down when we go to develop our tests. If your testers aren't included in the sprint planning, story points may not include testing, and that's going to affect velocity. What if defects aren't addressed on a timely basis? Of course, you can't address all defects, but you've got to address some of them, the major ones. Our regression suites can run too long or may not be effective, and this goes to test optimization and reviewing our scripts, making sure our test optimization and make sure our automation isn't flaky. It's something that we have to constantly keep on top of. And we need to make sure that our post-production checkout is automated. Sometimes that's still done manually, and that in itself produces a bottleneck. So basically what we really need to remember is that constraints impact velocity. Now, championing responsibility for quality. Again, that's probably one of the biggest aspects of continuous testing and probably one of the most difficult to implement. One of the ways that we can do it is making everybody aware of the status of our application. This is a dashboard that we use at Qualitest, but I highly recommend using any kind of a dashboard. Get it up, put it, post it, have it right where everybody can see it, because if everybody sees what's going on, if they see the need for quality, they're more likely to buy in and participate. But if they don't see what the stats are, they may not see the need for everybody participating. So, as much as it's difficult, using some sort of a dashboard is a good way to begin to get everybody on board with being responsible for quality. Now, how do we increase velocity and improve quality? Well, this is where shift left comes in. We need to push our automation to the base of the testing pyramid. I'm assuming you probably all heard about the test automation pyramid. The pyramid suggests it's the reverse of the ice cream cone. The ice cream cone, of course, is an anti-pattern. It suggests that manual tests should be very few, and they're right at the top of the pyramid. And going down to our unit tests, that's where the bulk of our automation should be. Because if we're doing our bulk of our testing in the unit and component levels, that's where we're going to be able to get our bugs fixed most cheaply, and it's going to streamline our testing and increase our velocity. We can use test-driven development and behavior-driven development. We want to make sure that we're implementing continuous non-functional testing. And we need to amplify our automated feedback loops throughout the whole decision-making process. How do we want to improve quality? Well, we want, again, with the test pyramid and the unit test layer, developers implement and embrace testing, the entire team being responsible for quality, and implementing that post-production monitoring to catch bugs before our customers see them. Implementing throughout the delivery pipeline. This means we've got automated tests at every stage. We're only maybe manually triggering our deployments. And implementing our automated checkpoints. Well, we want to make sure that our unit tests verify the code, our component tests verify the key features, integration tests verify workflows that involve multiple applications, our risk-based optimated regression suites run prior to each deployment, and they can even be targeted depending on what we're deploying. We want to make sure we've got our post-production health checks that are verifying the applications are up and running. And finally, our post-production monitoring are things like Mary releases and A/B testing. We want to find those defects and performance issues before they impact the customer. And shift left. We want to implement this with all that we do, not just our functional testing. We want to begin our performance testing as early as possible. We want and I think we talked about this a little bit before, but we want our functional automation tools to create multi-purpose scripts. We want to be able to do our cross-browser and cross-platform testing at the same time with one set of scripts. And we also want to make sure that our security testing is in place and we have automated tests that they're written in a secure manner and that security is thought of as early as possible in the process. Because that's one thing, when we find a security defect, those are usually back to the design and can be really expensive to fix if they're found late. So finally, continuous monitoring in production. Well, it comes from the principles of amplifying feedback loops. It enables collection and analysis of the data metrics throughout the life cycle. The most important data is about how the users are interacting with the application, and that's your feedback from the customers. Now this is important because it allows the stakeholders and the teams to make the most targeted adjustments, maybe functional enhancements to remove customer pain points, or even upgrading environments if performance isn't good. You want to test in production. This can involve anything from monitoring transactions and stimulating transactions to A/B testing and experimenting with real users. So to sum it all up, continuous testing is an approach to managing risk by focusing not only on eliminating bottlenecks, but increasing the effectiveness of our test processes. Automation testing is a subset of continuous testing. It is a key practice. It is the backbone, but it is not all that continuous testing is. And finally, our strategy involves streamlining the test processes, championing responsibility for quality, increasing velocity and improving quality, testing throughout the build and development pipeline, implementing automated checkpoints, shift left, and continuous monitoring and testing in production. And I have a few references here. And finally, I want to thank you all. And I really wish I could be there with you, but I appreciate your working with me over Skype. Thank you.